This is like the fourth time I've tried to make this video for you guys. So, I'm working with some new apps, so bear with me here. So, today, I want to talk about, in this video, type 1 errors. Okay, so you guys should have been reading about type 1 errors today. And what a type 1 error is when you run a statistical test and you reject the null hypothesis when the null hypothesis is actually correct. Okay? So, what does that mean? Let's say, oh boy, let's go back to my favorite example. And my favorite example, you guys know, is average height at Veritas Academy, right? So let's say I make a claim and I tell you guys that the average height of students at Veritas Academy is 62 inches. And you guys just don't buy it, right? You guys say, Mr. Sariola, we haven't done any samples yet, but we just don't believe you. There's no way that the average height of Veritas Academy is 62 inches, right? Well, given that example I just set up, the null hypothesis is going to be the status quo. It's going to be what I claimed, right? I claimed that the average height of all the students at Veritas Academy is 62 inches. So I have an H0, that mu, or population mean, is equal to 62 inches. And what you guys suspect is that the average height for the population of students at Veritas Academy is not 62 inches. So that would result in us having to run a two-tailed test for population means. And you can see that my alternate hypothesis down here is that mu does not equal 62 inches, right? So let's say we were going to run this test at the 5% level of significance, right? If it was a one-tailed test, we would take that 5% level of significance and we would put it all into the tail that we were testing, right? So if we thought that the mean was greater than 62 inches, I would put all 5% in the upper tail. If we thought the mean was less than 62 inches, we would put all 5% into the lower tail. But since we're doing a two-tailed test, I take this 5% and I split it up between both tails, right? So I got 2.5% over here, and I got 2.5% over here. And I drew in some arbitrary cutoffs. I just made them up. Let's say that we did our calculations and we learned about that while we were still in class, and we figure out that 2.5% of the time, given that what I'm saying is true and the mean is actually 62 inches, only 2.5% of the time would we get a sample statistic above 65 inches, and only 2.5% of the time would we get a sample statistic below 59 inches, right? And what we learned is if we get a test statistic that lands in one of these red regions above a critical value, and again, I'm not doing this with z-scores to try and keep it a little simpler. If we get a test statistic that lands in one of these red regions, we're going to say, Mr. Sariola, the probability or the p-value that we get a test statistic that lands this far away from 62 inches is so small that it probably didn't just happen due to random chance. We didn't get this sample statistic due to random chance. It's actually that your distribution is just centered in the wrong place. You think it's centered at 62, and it's not, right? And that's when we would reject H0, that the mean is equal to 62, and we would kind of be rolling with this idea that the mean is not equal to 62 inches, right? Well, as it turns out, if this is a sampling distribution of X bar, right? If all this information is true, 5% of the time, or really I should say 2.5% of the time, just due to random chance alone, I actually am going to get sample statistics that are greater than 65 inches, and I actually am going to get sample statistics that are less than 59 inches, given that what I'm saying is true. Which means 5% of the time, if what I'm saying is correct, I'm actually going to reject the null hypothesis when I shouldn't. Because these things still do happen purely due to random chance. They're just not very likely. And what that means for us is my probability of making a type 1 error is always equal to the level of significance of the test that I run. if I am taking the most extreme 5% of sampling statistics, and when I get those sample statistics, I'm rejecting H0. Well, if H0 is actually true, then I am actually going to be making this mistake 5% of the time, because the nature of the sampling distribution tells me that 5% of the time I'm going to get numbers in this region and this region combined. Right? So the important key to take away in this video is that the probability of committing a type 1 error is always exactly equal to the level of significance of the test. Okay? So I hope this helps you guys, and I'm going to work on some type 2 error and power videos right now.